Hey guys, so I'm Evan, I'm an LLM engineer at Gnosis, and this is a presentation on building the autonomous AI agent economy on Gnosis chain. So Gnosis, towards the end of last year, started the AI effort. It was a team of LLM engineers, and with the remit of that being to build proof of concept use cases for the agent economy on Gnosis chain. So agents being users of decentralized applications, competing for finite resources, and then the kind of emergent result of that being what we call the agent economy. And the kind of goal of this, apart from being kind of a research effort, is to onboard more users to Gnosis chain where users are agents, with the strong belief being that agents can be a large proportion of the user base of Gnosis chain going forward. So just for some context, where does this sit in the kind of AI Web3 intersection? So you've got kind of a division between these two things as far as I see it. First being an augmentation of the traditional AI stack with Web3 technologies, so things like zkML, decentralized compute. And then on the other side of the coin, you adding AI to Web3 applications. And that can be to help humans interact with the blockchain by using natural language instead of calling smart contracts, or having AI as a player in the game in itself. And this area is the kind of thing that we're focusing on in the team, and that's what we're going to be talking about here. Next slide. First question, where will autonomous agents be transacting on chain? I don't know about you guys. In my Twitter inbox, I'm getting daily messages about all these easy ways you can make money on chain. So at a high level, agents will be acting wherever they can make money. Lots of opportunities, I'm sure. But generally, there are kind of two areas where we see them being particularly well suited. And these are where having general intelligence beats out these kind of use cases where you can achieve the same kind of goal by ruthless scripting techniques. And the second is where the human general intelligence isn't being applied because the incentives aren't there for humans, because they have finite time. Agents don't kind of have those same kind of constraints. So with those kind of things in mind, the first proof of concept, the first use case that we took was prediction markets. If you were here for David's talk, you'll see some overlap between these presentations, but here we'll have kind of more of a engineer's practical guide. So prediction markets, for those of you who don't know, as an example of a prediction market there on the screen, the URL for this platform is there, AI Omen, where any user can go and post a question about a future event. So there's an example one here with a yes or no outcome, and then other users of this prediction market can purchase tokens in the outcomes, and placing a bet essentially. The market creator provides liquidity to incentivize this because there's value to them in knowing the answer of that question, and users want to bet because if they do a good job of it, then they have an incentive because their tokens end up having some value. The people who fail, their tokens become worth nothing. So the net effect of this is kind of an incentivization structure for the truth-seeking. So this was the use case we chose. Let's go through some additional. So this use case satisfies the constraints we saw on the earlier slide. But if you think about what you need to be a good participant in prediction markets, this is a set of things here which, again, mean that agents are very well suited to this task. So modern LLMs have very broad but also deep knowledge base. They're good at, if you want to make a prediction on some future event, you need to have access to real-time information. LLMs can do this research and when equipped with the right tools, do this research, and then are good at kind of aggregating this unstructured data to make a prediction. And then that final point we addressed already is there. Lots of times in prediction markets, humans don't have a sufficient incentive because the liquidity might not be very large, but agents don't have such a strong preference on that, and they can work for cheaper. Okay, cool. So we've picked our use case. Let's build our agent to act in this economy. So what do we mean by an agent? If you're familiar with the old kind of term of agent, this was something where used in reinforcement learning, where you have some parameterized model acting in some environment. It would receive some reward as a feedback, which would use to update its parameters accordingly. This is kind of not what we mean really when we talk about agents these days. We're talking about some system built on top of LLMs, and you have these kind of lots of Python libraries, a plethora of Python libraries that you can use these days to build these kind of systems which build on top of LLMs with some additional features. So let's go over these features. So LLM is the kind of core component of an agent, and that's used for the kind of general intelligence aspect. But then additionally, if it's going to be agentic, it needs to have tools that allow it to act in the real world. So for our prediction market, it's going to be doing some off-chain actions like web search and scrape, and then doing some on-chain actions. So this is our decentralized application, which is interacting with via Web3 library functions. Next, it's got some memory component. So our agent is stateful. It's going to be acting over a long period of time. It's going to remember, I didn't do so well when I bet on this market 3 weeks ago. Maybe I should consider how I research this topic in the future. And additionally, memory for overcoming context limitations of LLMs. And finally, for control logic, so you start with some kind of overall goal. I want to make money in this prediction markets. Breaking that down into sub-goals, managing the progress through a kind of run of the agent. And that's kind of what we call control logic. Okay, so let's illustrate this with a simple example. So here's just a snippet from LangChain, where we're just calling our LLM with the question, will it rain in Berlin tomorrow? If you do this, you run this, you'll get some response. I'm sorry, as an AI, I don't have real-time data access. So this is no use for our prediction market use case. It doesn't have any agency. So let's add some agency. So another snippet where we're using the LangChain agent library now. And you'll see we're initializing an agent. And we're passing in some arguments which look just like those features that we identified on the earlier slide. So we're adding a search tool, which allows it to go and scrape the web. And we're adding some control logic to say, kind of have this back and forth conversation, like you do with ChatGPT, except both sides of the conversation are managed by the agent. So now when you run it, you get much more useful information. It goes and recognizes it can't access, it doesn't know the answer, so it goes and searches the web, and then you get an answer. There is a significant chance of rain in Berlin tomorrow. All right, so sorry to be the bearer of bad news. Bring an umbrella. Don't say I didn't tell you so. Okay, right, so we've got our agent, the rough components we want to give it, and now there's a kind of big design consideration as engineers that we need to consider when building this agent, which is how much autonomy we want to give it. And this is a spectrum. It's not, so it's a design decision for the engineer. So take this top example, this code snippet. You've got a kind of set of functions which you need to be able to run to be a participant in the prediction market. So you're picking a market, you're doing some research, you're making the prediction. These things can each involve calls to the language model. But in this top example, this kind of execution logic is hard-coded. there's limited autonomy in this case. Then you can look at the second example, where you're now giving these functions as tools to the agent, and you're handing over the decision of how to call them, what order, how frequently, to the model. And then you can even imagine another case where instead of hard coding these tools and kind of statically giving this list to the model, you kind of give it the ability to search a marketplace of tools. And so this kind of adds a new degree of freedom to the agent. But with this kind of extra autonomy that the agent now has, there are trade-offs. And the main two being reliability and price, because the more the kind of agent has to think in the sense of generating tokens and reflecting on its choices, the more expensive that is, and then the more chance there is that the agent will go off course, make some mistakes, and so on. So that's something to consider. But we'll pick some point on that spectrum. We've now built our agent, and now the next kind of consideration that I want to talk about is observability and metrics. So this is a new kind of consideration for building agents that we didn't have to really think about when building other applications, because there's now this kind of fuzzy world of when you have a program previously, it kind of either works or it doesn't, and now there's a bit more kind of fuzziness in the ability to evaluate the model, where it's more of a question of like how well does it work, and there's like your kind of degree of uncertainty or like degree of non-determinism that's been spoken about before. So we kind of look for lower level metrics that we can evaluate our model on and produce kind of benchmarks before we deploy our agent to kind of see how it's doing. So in the prediction market use case specifically, the kind of metrics that we're interested in, how good is our prediction relative to the correct answer, or how good, and that's kind of measured after the fact, like you'll only know that once the market's closed. But maybe a proxy that we can use to kind of make benchmarking easier a priori is to compare our agent's prediction with some crowd prediction on existing popular prediction markets like Manifold or Polywrap. Some other considerations, more general observability and metrics considerations. This is the kind of final thing I'd like to talk about is logging and debugging of the agent. As I said, this is a kind of fuzziness for deployed agents, where the kind of output is natural language as opposed to like easy to pinpoint right or wrong results. And a great way to handle that is to use some kind of dashboard. There are these libraries which kind of really help with that by just adding a callback to your OpenAI API call, and then you kind of get nice execution traces of your agent, where you can see kind of which tools it called, how frequently, the kind of length of each step, and the number of tokens required. And that's great for debugging and optimization. Then, because our agent we're kind of sending it away with some resources in terms of a crypto wallet, and we're expecting it to do some work for us. There's a cost associated with it in terms of tokens and perhaps other API calls. And then the key metric is it kind of self-sustaining in the sense that the profit that it's generating is the sum of those two costs plus some extra. And then the final thing is also another kind of fuzzy concept. But if we've set our agent up with sufficient or degree of autonomy, then it has the capacity to learn over time. And that's by managing its context window to kind of prompt itself in better ways to produce better outcomes, and also to select better tools in a way that, again, produce better outcomes. And so that's another thing that you can look for in your agent. Okay, great. That's pretty much everything I wanted to talk about. Lastly, where to find us. So we have we have a June dashboard for all of our deployed agents that are working on the prediction markets use case, full of lots of dense information. You can check it out there. We have a couple Streamlit apps associated with our code bases, which are all open, that are kind of fun to play around with and to kind of test out how our agent runs through a kind of prediction and the kind of function calling aspect and kind of playing around with kind of agents that are currently deployed. And we have a couple GitHub repos, which again are all open, which feel free to take a look at and build your own prediction market agent if you'd like from our tooling repo. And we've got some examples as well. Okay, I think that's everything from me. Thank you very much. I've been told that John has been pulled off for some other engagement, so I'm going to manage the Q&A. So I guess, any questions, please, hands up. I've got a question over here.
Thank you. I want to ask about the alignment of these agents with humans' goal. Like, let's say you start off these agents with a $10, and let's say the agent becomes a millionaire, and they just keep making money. And what is the benefit for humanity of, is that goal aligned? Is it like making the predictions more efficient to help humanity to gain benefit from it? Or what other sense other than consuming energy can it have?
Yeah, sure. So I guess the agent is kind of given some, is deployed by some owner, so it doesn't kind of appear out of thin air. Someone's going to deploy the agent on their cloud or something like that, or in some kind of decentralized manner. And they're going to fund that agent with some crypto. And the agent is kind of being put to work on behalf of that owner. So it's aligned in the sense that the creator of the agent is giving it some goal to kind of set it going. Kind of as I was talking about in the presentation, with the kind of sufficient autonomy, then I guess there's an element of to what extent does it stay within these kind of guardrails set by the creator of the agent. But yeah, in terms of benefit to humanity, well, it benefits the owner if it is a sustainable entity. It's not essentially costing the deployment isn't kind of having a net loss, if that answers your question.
I thought like the owner would throw away the keys and then let go.
Send it off and throw away the key. I mean, I suppose a kind of key management is a kind of separate topic, but in this example, we're deploying the agents with a key and monitoring the performance based on that key. So, thanks.
Hi.
Hey.
I think we are always considering that this future with a lot of agents are going to be the end game, and then everyone will have an agent, and everything will be, based on agents' actions. But I'm also considering that they might fail, maybe a few times, and I'm just thinking, like, what are the possible risks on that, and what could make an agent fail?
Sure. I guess I can speak from personal experience of our work that we've done so far in the team. Yes, they at the moment aren't very good, and therefore in their current form aren't anything to be scared about. They're something that to be developed to the point where they're useful. So I guess for the time being, it's hard to say how long for. Failure is kind of inevitable, and there's, I guess, anyone who's developing an agent project is like just eating the cost of OpenAI credits or whichever provider they're using, in the hope that it becomes at least an order of magnitude like cheaper to run their agent, and the agent's capabilities improve a lot more to the point where they're being useful, like they're actually kind of making money or writing good code, doing good PRs, that kind of thing. Cool, thanks.
Hi, so I think you answered the question because I wanted to ask if it works
Okay.
and does it produce profit, but maybe, so what's your expectations? When it's gonna to be working better than humans?
Yeah, sure. So, yeah, to answer that question, I guess our deployed agents are currently profiting in the sense that they're like just taking the prediction market scenario of placing a bet, getting some returns on it, and making more correct bets than incorrect bets. So they're kind of doing the forecasting okay, but then considering the costs of the kind of LLM calls and the kind of additional APIs that they're having to kind of pay for to be able to operate, there's significant net loss. And I think it's going to be a kind of a gradual improvement with like small step changes when new models are released. So I guess everyone who's running an agent, depending on GPT-4, is going to wait for GPT-5 and then switch the flag in their agent, and then there's a kind of moment of to what extent does that alone kind of add in? Yeah, sure. I mean, so this prediction market use case is kind of constrained, or it's slightly artificial in the sense that like there's not a organic user base kind of creating the markets and like other users placing bets. So there's a kind of artificial environment in that a lot of the market creation is being managed by agents, the market resolution is being managed by agents. So we're not doing this as a kind of like side project to profit from prediction markets. It's like a proof of concept, kind of a research application in that sense. Why you don't want to make money? Right, okay, we'll double the bets and we'll retire from our day jobs. Yeah, okay. Thanks. Another question?
Great talk.
Thanks.
Actually, have you thought about the paperclip problem for pushing this to the limit? Like the agent predict the market. At some point, the agent will try to decide the market. Yeah,
sure. So in the prediction market case, there's the kind of incentives are set up so that if I get your question correctly, if the agents are kind of placing non-truth seeking bets to try and influence the result of the market, so that the market, so it says, yes, Trump is 100% going to win the next election, and then people go, oh wow, and that's going to influence other people's behavior. That kind of malicious intent.
Even more than that, for example, let's say something is going to happen, and it's going to do some terrorist attack or some crazy thing that like changes the outcome. Yeah, sure. So I suppose in this example, your agent has been built such that it has capabilities of prediction, of participating in prediction markets, and capabilities in warfare. And I guess it's maybe up to the... Let me do an example like COVID.
Yeah, sure.
I mean, the market, if you knew that if you knew that COVID was happening, you could have shorted the market. And the outcome from that could be higher. The incentive could be to actually do that.
Yeah.
So I wonder if an agent could do something like that, push into the paperclip.
Yeah, right.
Extreme.
I guess that's like a consideration maybe beyond the scope of this presentation in terms of like power being gained by super intelligent AI. For the moment, luckily we haven't got that problem. So thank you very much.